video, we are going to be proving that x plus 1 over x is greater than or equal to 2 for x, which is an element of R, minus 0. So for us to prove this, there are so many approaches to this proof. We can use the definition of the modulus, or we can use the properties of the modulus. But for us to use the properties of a modulus, we should first prove the property which we should use, right? So in this case, without loss of generality, we can prove this instead. That is what we should prove. So the first thing we need to prove is the property of modulus which we are supposed to use. So there is this property which says that modulus of x squared is equal to x squared. This is actually a straightforward proof. The proof for this one is since we know that modulus of x is equal to minus x and x for x less than 0, for x greater than or equal to 0. That is what you know. So it means that it implies that modulus of x squared is equal to minus x squared for x less than 0 and x squared for x greater than or equal to 0. This implies that modulus of x squared is equal to x squared for all x in R. So we can now use this particular property of a modulus. We can now use this particular property of a modulus. Okay, so I'm not getting back to what I want to prove. So I want to prove that x plus 1 over x squared is greater than or equal to 2. So suppose that, let me just say, suppose that x is an element of R. This implies that one over x is also an element of R for R minus 0, obviously. And what does that imply? It implies that if we take x minus 1 over x squared, this one gives us x, before that, we know that this is a difference of real numbers. The difference of real numbers is a real number. So it means that the difference of a real numbers squared will give us a real number which is greater than or equal to 0. Any real number which you take, if you square it, to give you a number which is greater than or equal to 0. So we're going to use this fact. So you can actually see that here, if we square it, we get x squared minus 2x by 1 over x plus 1 over x squared is greater than or equal to 0. Okay, what does this mean? What does this mean? This means that x squared plus 1 over x squared is greater than or equal to 2. That is the part which we have, because 2x by 1 over x is just equal to 2. We just took this 2x to the other side. Then after that, we need to add 2 both sides to form something which mimics x plus 1 over x squared. So we need to add 2 both sides. So by adding 2 both sides, we have x squared plus 2x by 1 over x plus 1 over x squared is greater than or equal to 2 plus 2. We just added 2 both sides there. The thing is, we know where we are supposed to go, so we should push what we know to where we are going. You can actually see that we want to prove that x plus 1 over x squared is greater than or equal to 4. So that's why we are actually manipulating this to what we want to see, right? So here, this one, if we factorize this side, you can actually see that you get x plus 1 over x squared, which is greater than or equal to 4. That is what we wanted to prove. But then, like, it is not enough yet. We need to retain the modulus but by the property that since modulus of x is equal to x squared, modulus of x squared is equal to x squared, this retains modulus of x plus 1 over x squared is greater than or equal to 4. Then after putting a positive square root there, we get x plus 1 over x modulus is greater than or equal to 4. That's the solution. Greater than or equal to 2. We're supposed to put square root there. That's the solution which we intended to find. So the proof is complete.